Okay, let's try this third cubic equation. Gee, it's in a nice form for finding x-intercepts and pretty easy to find the y-intercept. But it's a little bit, you got to be a little bit careful here to figure out what kind of shape it is. We have to do something first. I think we should do a switch around here. That is, make this minus x and then minus 2 like that. Now we know we've got a negative out in the front here. It's a negative a times the two brackets squared. And that is how I know that the shape is going down like this. So because a is less than 0. Now the y-intercept's pretty easy. Just put 0 in there. 0, you get minus 2 times minus 1. That's a positive 2, and that's just 1 squared. So the y-intercept is 0 and 2. And what is that? Right there. The computer says 0 and 2. That's where it's going through there. Okay, the x-intercepts, gee, that's so easy because it's in the right form. 2 minus 2 is 0. So x is 2 is 0. And minus 1 plus 1 will make y 0. You let y equal 0, and you'll find the x-intercepts, or the roots. And that's it of this cubic equation there. And so it looks like A is a x-intercept. Hey, it looks like it's a turning point too, and B. Now to find the turning points, we've got to multiply this thing out. I'm going to go x plus 1 times x plus 1 and then multiply it by 2 minus x. And I did it carefully, and I put the x's together, and you see it's 2 times 1. That gave me 2 minus x times x. It's minus x squared. And I got 4x minus x. That's plus 3x. Okay, that's your function. Now we can take the derivative, minus 3x squared plus 3, let it equal 0, and divide everything by negative 3, and you'll get this x squared minus 1. Oh, x is x minus 1, x plus 1 is how you factor that. So 1 and minus 1 is your are the x coordinates of the turning points. And just take 1 and put it back into the original function. You can put it into this one or this one. And what do we get for y? If we put 1 in, you get 4 back out. If you put minus 1 in, oh, we knew that, we get 0. Those are our turning points. And then the last question, the computer calls them extremums. A local maximum at E and a local minimum at D. Okay, I guess we could just call that A and D. It's the same thing there. Anyways, if we find the second derivative, take the derivative again, we get minus 6x. And if we let that equal 0 and solve it, we'll get the point of inflection. Well, that's when x is 0. But we know that when x is 0, y is 2. So there's your point of inflection. There's question 3 all done.